Hi everyone, I'm John, and this is ENLIGHT Insights, Knowledge Unpacked, where we explore the big ideas shaping our cities, societies, and futures. Today we are talking about urban digital twins, virtual models of real cities that can help us tackle climate change, improve energy use, respond to crises, and build more resilient, sustainable communities. And to guide us through this fascinating world, I'm joined by Professor Traore from the University of Bordeaux, coordinator of the Disrupt Network, which brings us together experts in AI, sustainability, ethics, and urban management to train the next generation of city innovators. We'll unpack what these digital twins actually do, why they matter, and how they could change the way we think about urban life. Let's get started. Professor Traore, could you start by telling us about yourself and your background? How did you become interested in what sounds like the intersection of cities and digital technology?
Yeah, hi everyone. So thank you for having me. So I am a full professor, as you said, at the University of Bordeaux. I have a PhD in computer science, and my research affiliation is what we call the IMS lab. IMS stands for Integration from Material to System. It's an interdisciplinary research component of the university that focuses on engineering and digital technologies. And my teaching is also in the university, but in the Faculty of Engineering Sciences. So my research efforts aim to contribute to complex system modeling,
Mhm.
computer simulation, and digital twin technology. And the application area can be summarized under a big umbrella that we can call cyber physical and human production and service systems. So that covers a wide area of application from industry to healthcare and territories. So today it's about territories because we are talking about urban digital twin, and the term urban is for territories.
Yes. How did you become personally interested in this?
I am currently leading a project that is a nationally founded project of the university. That project is called ACT, which stands for Augmented University for Campus and World Transition. And the aim of this project is to turn the university into a living lab for developing, testing, validating, and disseminating new ways to address major environmental, social, and economic transition issues. And within that project, I am in charge of developing the digital twin of the campus. And this is why I came to digital twin for urban territories. But of course, they asked me to lead this because one of the key words in my research is development and digital twin. And this, of course, is coming from almost 35 years of research activities.
35 years of research activities. That's fascinating. So, what exactly is the Disrupt project? And perhaps more importantly for our listeners, what do we talk about when we say urban digital twin?
Yeah, let's first say what is a digital twin? Not about the urban, but the digital twin. A
Mhm.
digital twin is a virtual replica of a real object, and this replica is used to test design and operational scenarios before transferring them to the real object, if they are validated. As an example, assuming a digital twin of a car has been created that mimics both the shape and behavior of a real car, such a digital object can be tested in various ways for various objectives and by various stakeholders. For example, a car engineer can conduct crash tests that can be harmful and expensive if they are done on the real object. But doing this with the virtual object, the engineer can find out the best design option for the car or some components of the car. A driver can use that virtual object to test and understand the behavior of that car. For example, driving on snow, driving on under raining, winding conditions, and so on. A candidate driver can use that virtual object to train and to just like what happened for airline pilots with flight simulator. And citizens also can look at that virtual car and then turn and manipulate the object and see what is interesting for them. For example, they can give feedback on the design options, the color, the shape, and so on. So that digital object can be for different uses, and it replaces the real object for doing some tests for some experiments under some scenarios and derive some decision or some conclusion that one cannot do with the real object without, expense, danger, maybe ethic issues, and so on. That is a digital twin. Now, an urban digital twin is the digital twin of a given territory. So what we call territory is something that gathers people together, like a building, a larger urban area like a district, or a full city, or even a peri-urban area. And you can extend this to the country and even to continent and so on. So we say urban because we have urban services concerned, like mobility, transport, logistics, urban logistics, transportation in the city, things like waste management, things like energy consumption and production, healthcare services and supply chain and so on. Whatever you are interested in the city or in the peri-urban area in terms of service that you want to optimize or to manage using the digital object, then you build an urban digital twin that can mimic the reality and that can help you, achieve your objectives.
So, like when we say a digital twin, we are basically talking about a simulation, right? For example, a simulation has applications in biology, in physics, and like in different areas of science. But
Yeah. But it's much more than simulation. That's why the term is different from simulation. By the way, my initial background research is modeling and simulation, and then it has evolved to digital twin. We can do simulation, but in some cases, your digital twin may just take data and infer some conclusion, like diagnosis. Like you go to the doctor will just monitor something on you and say, oh, you have fever, or you have this, or you have that. That is diagnosis without simulation. But you also need to predict. Then this is where simulation comes, like saying, okay, if you continue like that in 3 days, you will die, for example, or you will get better if you do that way. So that is predicting, forecasting what will happen. But you can also optimize. So the digital twin has different capabilities. It has simulation capabilities, but it has also diagnosis capabilities. It has also optimization capabilities. It can be used only, for example, for monitoring. Like I want to monitor my energy consumption, and on my cell phone, I have like a display of my current energy consumption. So it can be only this. So we call those things services or capabilities of the digital twin. So it's a kind of putting together different techniques that we use in model-based and data-driven engineering, putting them together in a kind of framework that will allow you to have a, let's say, full-blown tool for supporting management and decision making of complex systems.
yeah, like for example, we are not talking about like a 3D video game version of a city. For example, if you created a digital twin of Göttingen or Bordeaux,
Yeah.
what would that actually look like? Like what kind of data are you feeding into these models?
Yeah. So if you look at cities, they have different priority areas, even if they all share the same urban issues, due to the ever-growing demography-based pressure that is being exerted on urban systems in that global context of climate change and the need to reduce the carbon footprint in all urban activities. So cities have different priorities, and cities are not at the same pace, of course. But all of them can use the urban digital twin approach to make things easier for them. So see it like a digital sandbox where you have a representation of the city, not necessarily a 3D representation, because sometimes people think digital twin is a 3D thing. It's just a model or a sequence, a series of models that allow you to derive conclusions. So sometimes the 3D is necessary because your conclusion is based on geometry or shapes. But sometimes your conclusions are based on position, location, quantities, trends, and then you don't need a 3D representation. You need a representation that will help you get to that conclusion. So it's not just a unique shape. A digital twin has to be seen as a collection of data and models of different shape, models that are visual, models that are just dynamic model, control model, and so on. And the only thing that makes the difference between the digital twin and a traditional model for simulation, for example, is the fact that data that you are collecting is also assimilated into that model. In traditional modeling approaches, we build a model, we validate, and then we use that model to derive conclusion. In digital twin, you don't consider your model is done and once and for all. You consider that that model has to be updated regularly with data coming from reality, so that the knowledge that you have is the knowledge of the physics behind the reality, but also the knowledge of what is happening at the operational level to the reality, like it is raining or some accident has happened here, something has been dropped. So what you are expecting as behavior may have been changed by this new event. So taking this into account, make your model like a living entity. Then you have a digital twin.
Yeah, so like
Doing this for city is urban digital.
So like, for example, like infrastructure is like a crucial thing to take into consideration, right?
Yes.
And like when we have more problems, we take these problems into consideration as well, and we adapt our project accordingly.
Exactly. And then also, imagine the city is something that grows. The city, so you build a model of the city today, in 3 years, your model is obsolete because some new districts have been created. Maybe some streets are not one way anymore. There are two ways or the opposite, somewhere two ways. You have created some roundabouts. You have more people in some places. And if you don't integrate those new information, the model that you have built 3 years ago cannot be used to take decision. So the digital twin is a model that will gradually adapt to those new things happening because data has been collected by different means. It's not only sensors, it can be from different sources. But you integrate those data and you update your model as reality is evolving.
So basically, like population is also so important, right? Because as the city gets bigger, it has more population, more problems can arise. So actually, the background of the city is very crucial. But for example, how do you balance the benefits of all this data collection with, like, for example, privacy concerns for citizens?
Oh, yes. Privacy is something that cannot be alienated. It's something that has to be guaranteed all the time. So data that are collected, for example, for an urban digital twin can be mobility data, the number of cars in a given place or the number of vehicle in a parking or how many vehicles have passed this position. In energy, you can have a record of energy consumption and so on. Okay, so you build models based on your knowledge of the physics behind, but also updated with the data. But you don't use individual data as long as privacy is concerned. If it's like urban assets, there is no problem. You can record let's say, a public light, you can record the energy consumption, and you can build in your digital twin an avatar representing that public light. There is no problem. But you cannot, for example, represent in your digital twin someone who is behaving based on the data of a real person as an individual isolated from others. What we do is to aggregate data from different individuals, anonymize them, and use those data to define trends. You define trends. For example, if you do a model for traffic, you have different behavior for drivers that you put in your model to simulate reality. but those behaviors are not based on individual behavior of someone that you have selected. You have to get some average information.
Yes, like for example, so every person is kind of averaged out in this whole collection, right? So
Exactly.
it's like sociology instead of psychology, right? We are
Exactly.
looking at the bulk
Exactly.
of people.
I like this analogy. Yeah.
Thank you. So, and this is like a huge project, right? And you are coordinating this network across 6 universities,
Yes.
from Bordeaux to Göttingen to
Yeah.
Tartu.
Yeah.
That's quite an undertaking. What made you realize this needed to be tackled by such a diverse international team?
Yeah, okay, many reasons. First reason is that, as I said, cities have different priority areas, but they share some common concerns. If I say mobility, energy, waste management, and so on, all cities have those kind of problems, but not necessarily in the same level of priority. So the more experiments you do, the better it is in terms of knowledge gaining and sharing, so that maybe a city that has a priority at a given moment, when it will shift to another priority, can benefit from what has been discovered, that what has been developed and done by another city. That is one reason, mutualizing things so that we have like a pool of solutions that can accelerate the development and the deployment of digital twins in different cities. Second reason, which is more motivated by the European Commission, is that the European Commission has launched a sequence of calls to support the development of urban digital twin. They call it local digital twin. So there is an initiative called livingin.eu that has been founded by the European Union. I think it's in 2022, if I'm not wrong. And that project is gathering more than 140, I think it's 149 cities in Europe developing local digital twins. So they put together the tools in a toolbox, and they have also experts, and they are trying to help cities adopt and deploy the digital twin solution. And now the trend of the European Commission is to say it will be interesting to connect those digital twins together. So instead of having a physical twinning of cities, we can now have the virtual twinning of cities. So cities will be connected through the digital twins, and mediation can be done in the digital twin area, in the virtual area, in addition, of course, to the physical one. And you have a lot of benefit. The benefit you have for using the digital twin at the level of a city, you will now make it bigger because you connect to other digital twin, and you can, let's say, exchange a lot of things through that digital twin, depending on what is your common concern and what you want to share together. So that's the second reason. A third reason is something that is more, let's say, scientific. The digital twin technology is not simple. It's, as I said, it's putting together different technologies. So it's about Internet of Things because you collect data. It's about data science because you integrate different type of data. You have to analyze those data. You have a huge amount of data in some cases. So you need people that are data scientists. You need people that can do modeling and simulation. So people who are concerned with the physics behind reality. For example, you have people in simulation with simulation techniques. Sometimes your digital twin is computationally greedy, let's say. So you need people in high performance computation. When you interface your digital twin with the idea of immersive environment, like 3D, but also immersive, like people wearing augmented reality devices, and then, being in immersion in the digital twin, you need people, you need scientists in augmented reality, virtual reality. So you also need, in the case of urban digital twin, people in urban planning and development. You need those people because they have the knowledge, the true knowledge about the urban services. And you also need people coming from other social and human sciences, like technology acceptability. It's not all to build a fancy digital twin. Nobody will use it because, it doesn't really take into account human aspect. And then when you create a digital twin and you make it accessible to people, you may also create some inequalities because it's not like everybody has access to digital environment the same way. Some people may not be able to benefit from that digital twin because they don't have access to the digital environment. Some people may not be able to use your 3D, your fancy AR devices because they are blind, and so on. So you have to also think of what you create in terms of social equalities, inclusion, and so on. So you don't need only scientists, technology people like me. You also need people who are at the philosophical side, at the sociological side, and so on, so that you don't build something just to please computer scientists. We like building those kind of things. It has to really address, real concerns and be of benefit. And the best way to realize this is to put together scientists from different horizons. And international collaboration is much, much more beneficial than, trying to develop something alone in a corner.
Yeah, that was an amazing answer. And like because your project involves diverse fields basically, so you need people like international people and with a diverse background, right?
Yeah.
And also I was thinking of that we are in the age of AI and information, so more data will lead to basically more consistent and sometimes better outcomes, right? That's why you
Yeah.
need like diverse teams with more massive data, basically.
Yeah, that's true.
Yeah, and your project mentions using digital twins for disaster and disruption prevention. Can you just
Yes.
walk us through how that would work? How does a digital model help prevent real-world disasters?
Yes. So one good example is the pandemics. So in terms of mobility in a city, of course, when there is pandemics, you can see easily how the public transportation can increase the spread of the disease and create clusters in different areas. And you need to study, first, you need to understand how that spread, the dynamic of the spread, and also you need to explore the impact of different mitigation measures. So it can be like wearing masks, but also you can restrict some traveling areas. You can, decide that a limited number of people can enter the tram at a given moment, and so on. You have a bunch of mitigation measure, but you need to evaluate to assess their impact. So your digital twins, because it allows you to do simulation, will allow you to do this what-if exploration, what we call what-if exploration. What if I do this? What if this thing is happening? So then you can find the best option in terms of mitigation measure and then implement it. That's an example of disruption management. Disaster is when, for example, you have a flooding in a city, or you have fire, as we have experimented in Bordeaux some years ago, in the peri-urban area. So you also use the digital twin to do simulation and then forecast and then decide how you can, in case it happens, how you should react, but also maybe in anticipation, what should be done or what should be avoided to just avoid being in such a situation. So your digital twin can be used for that. And the difference, once again, with a traditional model is that the simulation you are doing is more accurate because it has integrated what has been happening all this time to your territory. So, for example, for fire, of course, the forest is growing, the area that are inhabited are also changing. If you don't integrate them, then you will simulate something that doesn't correspond to reality, and then you may not derive a good solution. Now, for stress and disruption in a general case, let's say you have, for example, a geopolitical crisis, like what is happening for a while in Russia, Ukraine. It has impact on energy supply. Then in your city, you have your digital twin is, for example, also about energy consumption, energy production, and so on. Then you need to anticipate those kind of situations and do what if scenario exploration. What if in the supply chain of your energy supply chain, what if one of the nodes, a provider or a distributor, has failed or the capacity is reduced? What if? So that what if exploration is behind the idea of assessing resilience, so finding mitigation measure that will allow you to continue functioning even if the situation is not as usual, and also being sustainable because you also monitor your activities and you try to find the best option to reduce your carbon footprint in your different urban activities. So those two keywords, resilience and sustainability, are particularly of interest when it comes to using urban digital twin.
I was gonna ask you about this carbon footprint as well, but like first I wanted to ask you this forest fire situation. For
Yeah.
example, in order to understand the impact or like in order to understand the preemptive situation about forest fires, you need to have an idea of the density of the forest or
Yes.
what types of trees we have in that forest, right? But
Yeah.
like, doesn't that require like a huge amount of data? Like basically like a real twin, right?
Not necessarily. Then this is also something we do in simulation. We create a model that are very detailed, but very computationally expensive. But sometimes we create what we call surrogate models, models that are light, but they run fast and they give you approximated answer. But it depends on your level of decision. Let's take an example. I have a forest. And I know the dynamics of how the fire will spread. I can build a model that is very detailed with the essences of the trees, the position of the trees and so on. And of course, this is very computationally expensive. And I need also to collect those data maybe with cameras and then analyze the images and then, and so on. But I can use Google Map that will show me the coverage of my forest with less, computational expense, and then use a 2D simulation with some rules that somehow are approximation of the fire spreading rules at the very detailed level. And I still can come with some conclusion if the area I'm considering is large enough that are good enough to take some decision. So it depends on the level of decision you want to take. And of course, the more, let's say, low level decision you want to take, the more computational expense you will have and the more detailed model you need. And in reality, we use what we call multi-resolution models. Like in army, when you are, you have the tactical level, the operational level, the strategic level. You don't use the same kind of models, and they are not detailed at the same level. It's exactly the same for all type of digital twin, and for urban digital twin, of course, it's really, it's obvious.
Yeah, so like it depends on the urgency of the situation, right?
Exactly. Yeah.
So climate change and sustainability are like clearly central to this wrap. How do these digital twins help cities reduce their carbon footprints or manage energy better?
Yeah, so the digital twin we are building, we already have something. The format of our interview doesn't allow to do demo, but I could have shown you a demo of our model. So we have a model that is integrating mobility and energy together because they have an interplay.
Hmm.
For example, if you are interested in how you locate your electric charging station for electric vehicle, you need to maybe analyze your mobility scheme and then place your station at the best places where, you optimize the access to them. On contrary, or on the opposite, when you deploy your network of charging station, then you may influence the way people will now move, and then you may change the mobility scheme of the whole city. So they have an interplay, and I have several other examples, building occupation, mobility in a building, and the consumption of the building, and so on. So we have a digital twin for that. And as I said, it's for different stakeholders. At the higher level of decision, we have the policymaker and the urban planner of the city. So we are developing it in the campus of Bordeaux. But remember, we are turning the university into a living lab, and we find solutions that can be now applied to the whole city. So the decision maker at the university can test assumption. Let's say we have a level of CO2 emission at a given time, and we want to see what are the measures that will reduce that level. Closing a parking, closing a street, enlarging some areas, and so on. So you can test different assumptions, and with your digital twin, you see the impact of that decision on the level of CO2 emitted in a year, in a month, in a week, and so on. So then you can choose the best option and implement that option to make your mobility greener, for example, or less carbon emission. And the same for the other aspect. As I said, this what-if scenario exploration is a way you use that digital sandbox, and then you play with it in the sense of you test different assumptions including what could happen in terms of disaster, in terms of stress, in terms of exceptional situation, like an Olympic game going on or whatever, there is a riot or there is something going on, and you can test that before it happens. You can just enumerate different possibilities, but also your mitigation measure. You can also have a bunch of mitigation measure, and then you play those two things one against the other. So you can explore a landscape of scenarios where you have situations that can happen and also mitigation measures that you can take. And for each of them, you have key performance indicators that you calculate in your digital twin, like the level of CO2, like the amount of occupation of your different assets, whatever performance indicators is interesting, then you make your model calculate. And then you can optimize because you have explored the landscape, and then you can choose the best option, whether it's the minimal value or the maximal value that is good for your case.
Yes. So your project description talks about developing circular economies and preventing disruptions in supply chains.
Yeah.
For our listeners who might not be familiar with these terms, can you explain how digital twins help cities become more circular and resilient?
Okay, so the circularity, let's say circular economy means that let's say you put in place a system where you reuse or you regenerate some products. Okay. What I'm saying is not necessarily for urban digital twin, but for digital twin as a tool. You can use it as a decision support tool for achieving circularity. Because when you want a circular economy, you need to be able to have the traceability of your product, and also to be able to take decision of regeneration, decision of reuse. You should be able to say, okay, at this point, this product or this asset can be reused or should be dismantled. And when we dismantle, maybe we can reuse part of the component, or, it has to go entirely to trash. So that decision is not easy because you need to evaluate the health status of your product and then also the quality of the component. And traceability is key to do that because once you create your product, okay, you know the value of the product, but as the product is going through its life cycle, of course, you lose visibility on how the quality will evolve, how the quality of the component and how the quality of the whole will evolve. A digital twin will help you ensure that traceability. If you collect data on the product through its life, then your digital twin contains those information. And at any time, you can ask the digital twin to evaluate the health status. And based on that, you can take a decision on, reusing or regenerating. And this you can apply to any type of product. You can, for example, for urban digital twin, it can be for waste management. You can apply that to that level. But you can apply to, for example, your urban infrastructure, your assets, urban assets that are having a life cycle, and then you monitor that life cycle. And for example, a city hall, a mayor can have a fleet of vehicles for emergency response or whatever. And that fleet needs to be, monitored in terms of, the lifetime, what is happening to the component of your fleet, and when do you need to regenerate something, and can you reuse some component for some other objective, and so on. So the digital twin can help. But of course, you need to do some serious work on the type of model you have to build inside your digital twin, considering that aspect and the objective that you have in mind. But generally speaking, we have used digital twin in circular economy, not for cities, but for economy. I mean, in the project I'm leading also in that area is about a company. I don't know if I have the right to name the company, but the company is selling electric bikes and electric scooters, and they want to have a circular economy on that. Like when they sell the electric bike, later on the bike may come back, maybe to change the battery, or maybe the user will be changed and the electric bike will be reused for another user, or at a certain point they dismantle the bike and component of the bike or the scooter will be used for something else. So it's a huge project, and they want a digital twin to be built to support this. And this can be integrated in, for example, the urban management, as long as it serves the urban services. I mean, it's part of the urban services. Imagine, for example, the cities with renting bike that you can rent in a city, and then you can use it for your mobility. So you can, these are places where the digital twin can be helpful and to achieve circularity for the city.
Yeah, and as long as we keep it updated, a digital twin can help us adapt to various scenarios, right? Basically,
Yeah.
that's the idea.
Yeah.
And here's what I'm curious about. When you go to a mayor or city council and say, we want to create a digital twin of your city, what is the reaction like? Are cities ready for this kind of technology?
Yeah, so as I said, that the European Union has massively invested in this, and you can see many cities in Europe have already adopted and deployed digital twin. Like Helsinki is very known for having done that, but also in the UK, I have visited some collaborators, and I've seen quite a couple of cities with their digital twin. They don't focus on the same thing. Some are more mobility, some are more waste management, some are more, and so on. Some can have different 2 or 3 concerns, but the Living in .eu initiative has a platform, and if you go there and you Google, they are talking about more than 140 cities that have adopted already and developed partially or fully a digital twin. But of course, all cities are not going at the same pace. In some places, they don't have a digital twin and they are far, very far from it. They are fighting to digitalize their services. So, which is like, let's say, the a step that is the first or second step before you get to the digital twin. So I don't have an overall view of how people react to the idea of developing a digital twin, but the cities and collectivities I have been in touch with, they all are interested in the idea. Some are figuring out what is a digital twin, how it can help. We have heard that it is helpful, but we don't know what it is and how to implement. Some have already some technology in place and they want to turn this to digital twin. They say, what are the steps to move from where I am? I have databases, I've collected a lot of data, and what should I do to move to the digital twin level? And of course, some are driving projects, some are running their own digital twin projects. So I think there is a variety in such a case, and I guess the bigger the cities are, the more awareness is there. And if you go to small localities, probability is high that they are the one needing more information, more technology, more help in building the digital twin and understanding how this can help them.
Yeah, but like you say that some big cities are ready to adapt, right? So it's so good to
Yes.
see that. Yeah. Normally I would think that because some cities are like so big, they would resist because it takes a lot of work to, get into
Yes.
this digital twin.
Also, yeah.
So
But
your
but the,
twin?
but the big
Yes.
cities, they have also human resources, because
Hmm.
sometimes the problem is also human resources for developing, but also for maintaining the digital twin. You can call a provider to build your digital twin, but how do you maintain? How do you make sure that this digital twin will be fed continuously with data and things will be, So so you have different questions here.
Yeah, like maintaining it is as important as building it, right?
Oh yes.
And you need a lot of people to maintain that, basically.
Yeah, not the number of person, but you need the skills. You need people who are skilled to do that. Yeah.
And for that, like you're training young researchers in this field through like
Yeah,
annual
exactly.
schools and
Yeah,
webinars. And like
exactly.
what kind of skills do they need? Are we talking about computer scientists, urban planners, engineers, or like, yeah, all of them maybe?
Yeah, it's a combination. The digital twin science is a true science. The digital twin technology. If you don't consider only urban digital twin, but you say the digital twin, because you can see it really like a transdisciplinary object. It's merging these different disciplines, not putting just discipline side by side, but merging them. Artificial intelligence and modeling and simulation has to be merged together, and then you have to merge this with IoT. You have to merge. It's not just, like black boxes talking to each other. You have to get something that is merged. So we need to train that generation of scientists. We consider that cities will need this. All territories, not only cities, buildings. Even if you are in a private building, I think that in the long term, we will have digital twin of building that the building manager, or the company is in charge of it, will use for energy monitoring and for different things. So we need people who are skilled, but that skill has to be a combination of different disciplines, as I said. You need people to understand what is complex system modeling, so the physics-based modeling, but the non-physics-based modeling, the human behavior modeling, for example, agent-based modeling, those kind of things. We need people who understand the technologies, implementation technologies. Like today, there is no unique platform where you can develop your digital twin from A to Z. There is no software or platform where you can say, it will allow me to declare my IoT, to collect my data, to analyze my data, to build my models, to feed my model with the data, to optimize, and so on. There is no such tool. So all solutions are aggregation of tools. You have a tooling framework. You have to select best tool for each of the components of the story, integrate them together in an efficient way, and then deploy and make it run. So we need people to understand that. We need to train scientists so that they are able to integrate technological solutions. They can do abstraction in modeling. They understand what optimization means. And they also need to put this in the context of urban systems. So they need to understand the urban issues, urban challenges, and all those aspects that I've mentioned. So yes, it's a unique program. And if you look at the landscape of the European education and research system, there is no training that is adequate. You may find pieces of this and that, and if you want to get a complete skill, you need to pick them here and there. And we want to put those knowledge together so that we train in a way that you get that unique combination of skills that will allow you to develop, maintain, use efficiently urban digital twins.
Yeah, I was gonna ask you about the technical side as well, because you said that there is no single application that can manage this. So are you working on an application that can implement all of these various data that are coming from various fields?
We are building tools, but I don't believe, honestly, that there will be one unique tool to that. There will be a suite or different suite of tools. But one unique tool, I don't think it's realistic. It will be like integration of different tools. Of course, one can come and say, oh, okay, this is the suite, and that suite contains different tools, and it's one tool. But just imagine with Microsoft Suite, you use Excel for something, you use Word for something else, and so on. So this is a suite that is for bureaucratic operation. Digital twin is the same thing. You need tools for taking care of just the data collection, like the sensors, the IoT, the Internet of Things element, the declaration of things, and putting them together. You need some tools that are good in analyzing the data, cleaning the data, creating the data, and extracting information from the data. These are totally different tools from the first one I have seen now. You also need to be able to build models. There are tools that exist also where you can build, simulation models. You can use Simulink, MATLAB, AnyLogic, and so on. Okay, these are good tools, but they are good for doing just that part. You need also to integrate the data within the models, update your model with the data. So you need to do something there. Sometimes you don't even have a tool. You need to develop, you need to code some pieces of program. And if it comes to the immersive aspect, you need also to use tools like, I don't know, Unity that are good for, 3D and immersive solution. And it's not likely one tool will allow to do all those things,
Yeah.
So you need to integrate them. You need to create, bridges so that you have your full solution. And at a given point, that this is the tool that is called that will do it very good. And then at another point, another tool is called, and of course, there is a kind of alignment, semantic alignment between the tools. Then this frame, this tooling frame, you can call it a tool again, of course, a platform, whatever you want. But yeah, definitely, I think this is likely what will happen instead of, for example, developing an entire tool using, for example, Java or C++, and having all those functionalities I'm talking about from data collection to the final result at the other end.
Yeah, I think of this as an AI using function calling, for example, when it needs to do something with math, and it uses like Python.
Yeah.
And when it has to search for, I don't know, something on the web, it uses web search function. Like whatever the tool that is needed,
Yeah. That's
AI
a good
employs
idea.
that.
Yeah, definitely. You can orchestrate using an AI. Orchestration of the different tools can be done. But if you look at the whole picture, That orchestration is one of the components of your whole thing, where you have different tools doing different things and aligning different things. Yes, yeah, the solution, there may be different ways of implementing and coming to a platform. There may be different solutions, but the one that you are mentioning definitely is a good, idea in terms of, okay, I need to integrate things, I need to align them, and maybe AI can help doing it the best way. Yeah.
It's a fascinating interconnected project. Are there any cities around the world that are already successfully using digital twin technology?
Oh yes, the first urban digital twin, or the first city that have developed digital twin is Singapore.
Oh,
So the Singapore digital twin is very well known, and it's a real 3D, very realistic rendering of the Singapore Bay. And it's also accessible on by internet. You can just Google Singapore digital twin, and you will be able to access to it. You will have the visualization of the Singapore Bay, and they were interested in how wind, because Singapore, the configuration is in a way that the building that they've created are so high that the wind that is coming has a specific behavior, and they wanted to understand the impact of that behavior on some different things. So they built this digital twin, and they continued, extending the digital twin to represent the whole Singapore. So this is the one that is really number one. But for example, Tokyo also has a digital twin that can be accessed online also. I don't remember the name. Yeah, I think it's like Mini Tokyo or something like that. And it's more about, you can see, for example, it's transportation. You can see flights, currently coming, currently taking off. You can select spots in the city where you see if a tram is passing or not. So it's more monitoring. It's less simulation and prediction. It's a monitoring of the city of Tokyo in terms of public transportation. Helsinki, very well-known digital twin in Europe. And there are many, many others. In the UK, for example, Liverpool, Manchester, Torbay. Yeah, there are many, many, and of course, they don't focus on the same thing. Torbay is about flooding, because this is a coastal small place, and they are very concerned with what happened in case of flooding. They have residential areas, but also industrial areas. And with the digital twin, they try to anticipate on how to manage this. So there are different cities that have successfully deployed and are using the digital twin. Yeah.
it's amazing. It's amazing. If we fast forward 5 years, what would success look like for Disrupt? What changes would you most want to see in how cities are planned or managed?
Yeah, the success for us, we are academics. So as an academic, the first success is the impact that we will have on the educational landscape. So what would be good is to have a master program on digital twin engineering, urban digital twin engineering and management, and use for sustainable and resilient territories. And of course, having PhD programs co-supervised between partners on that topic. That is at the academic level. That's very important for us. And of course, we think that this will have impact also on how the technology will be adopted by the cities. So if we reach the level of this so-called cityverse that the European Union is promoting, that will be a success. Cityverse is for smart city and metaverse. So the ambition is to say, we will have digital twin of the different cities connected together, and it will be in a unique space that is an immersive space where you have avatars of people and urban assets. And then mediation can be done there. And you can have a true management of the city using that tool. Of course, not exclusively. It's using the digital with the real, with reality. But as with augmented reality, you bring something that increase the quality of decision making. You don't replace, you don't substitute, you increase, you bring more than what is done currently. So the success would be if we understand that we are not substituting, but we are trying to bring augmented digital solution to the management of different cities. And doing this in the metaverse, in the so-called cityverse, would be a sign of success of the domain, the area itself.
When we
And
say
you
like
see things like ChatGPT, large language models, can be used in such digital area to really derive some decision that you cannot take, you cannot even compute in the real world. It's an accelerator, so you can use huge amount of data. You have cities connected together. You can have some correlation that you cannot compute, you cannot see in the real world, and you can make huge progress in that domain.
When we say, for example, metaverse, do you mean Mark Zuckerberg's metaverse, as in Facebook and Meta?
Metaverse is a technology. So Microsoft say metaverse like it's their product. It's not their product. Metaverse is a technology. So it's when you have avatars in a digital world. That is a metaverse technology. Now they decided to also say metaverse. They should have named their technology, but they say metaverse. But the metaverse in the scientific area is a concept. Yeah.
Okay.
So digital twin merge, the concept of digital twin merge with the concept of metaverse is when you bring everything we said about the digital twin in that virtual area where you have augmented and virtual reality, you have avatars, so that if I have my avatars, then my avatar may behave based on data collected from me. And of course, this is where we will seriously need to solve the problem of privacy, because there you don't aggregate necessarily. When you have an avatar, then it will be individualized. And it depends on the use you want to do with such an avatar. For example, in medical areas, it's very useful because then decision to care someone can be taken based on much, much more information. But then you have to deal with, the breaches that that such a technology can provide, and people make use of personal data for some other reasons. Yeah, this is a challenge that is, coming. Yeah.
Yeah, I just wanted to make it clear because when you say metaverse, some people might think that it's the metaverse of Zuckerberg.
Yeah.
So, the last question. For our listeners, whether they are students, city residents, or just curious about the future of cities, how can they learn more about urban digital twins or get involved in this field?
Yeah, even if the field is emerging, even if that field is in its infancy, there is a huge amount of literature from the scientist aspect. So if you Google with keywords, digital twin, smart cities, urban digital twin, local digital twin, you will get a huge amount of literature at the scientific side where, you can learn about digital twin. And as I said, some of the digital twin have a platform freely accessible. So very few of them. That's true. Like maybe 5 to 7 cities have a part of the digital twin you can access freely, and you will access to maybe a limited set of functionalities. They hide the most interesting part. But you can learn from that. And there is a hype currently, the notion of 15 minutes city concept. they say a city must have services accessible in 15 minutes. All services must be accessible in 15 minutes. Like in reality, for example, I want a city, a place where the post office, I can get it in less than 15 minutes. If I want to go to a bank, I can get it to less than 15 minutes and so on. If I want to go to a tram station and so on. So with a digital twin, they want to realize that concept. Like with the digital services, you can have services that are accessible in a click or in 2 clicks, you know? And I think this one is a hype and it's becoming a reality slowly. And you can read about those kind of things when you go on the European Union, European Commission platform for Horizon Europe, because there are calls and they somehow they are drawing the future also. They are that if you read the calls, if you read the intention, somehow you see where we are going or where we are trying to go. What are the big trends in terms of urban digital twin?
Do you think it is achievable to reach places in 15 minutes?
Services can be reached in 15 minutes. Not 15 minutes, but in clicks. Because, of course, if you digitalize that concept, you will talk about, something similar, which is clicks. So, for example, maybe a bunch of services, digital services, can be accessible. Let's say I want to go to some place and I want to rent a bike. I will use what you do now is to use your cell phone to do the renting and so on. So somehow you are already, you use Uber, you use intelligent digital assistant, you use digital stores. So putting all those things together, not on a cell phone, but in a digital twin, where you have, in addition to the services, you have the representation of your city. So it's not just asking for a service, it's also monitoring, maybe acting on, maybe predicting, and so on. So, you have added value there.
Yes, it's like a complex simulation.
Yeah.
Thank you so much, Professor Traore. It was like
Thank
an
you.
amazing talk. Yeah.
Thank you very much. It was a pleasure.
That's all for today's episode of ENLIGHT Insights Knowledge Unpacked. A huge thank you to Professor Traore for sharing their insights on how urban digital twins can help us build cities that are not only smarter, but also more sustainable and resilient. If you enjoyed this conversation, make sure to follow the podcast and check out more about the Disrupt Network. Thanks for listening, and until next time, I'm John, and this has been ENLIGHT Insights Knowledge Unpacked.